Data Skeptic features interviews with experts on topics related to data science, all through the eye of scientific skepticism.
Delia Rusu has a PhD in computer science from the Josef Stefan International Postgraduate School in Slovenia, focusing on machine learning and natural language processing. After graduation, she took the role of chief data scientist at Gnosis, a social media analytics company which provides insights to capital markets using unstructured data. She recently presented a talk at PyData London and PyData Berlin titled Estimating Stock Price Correlations Using Wikipedia. It is this interesting line of work I invited her on the show to discuss today. Delia, welcome to Data Skeptic.
Hi, Kyle. Thank you for inviting me.
When I think of stocks and the market and things like that, of course, the classic time series stock ticker comes to mind. I thought maybe a good place to start would be to ask, what sorts of data do traditional stock traders use? If we for a moment put aside the interesting stuff going on now, what did the landscape look like maybe 30 years ago?
Sure. So traditionally, the data is pricing data. So you have a lot of information about a company and its performance in terms of the actual numbers. You have traditional providers like Bloomberg, Reuters, and the like, which offer abundant pricing data related to a variety of companies.
So when I see those stock charts, my instinct seeing a time series like that is, why don't I go do like some smoothing or some ARIMA or something like that and ramp up my portfolio? So I guess my question is, why do I need to look at outside data? How does that help me?
The problem with the traditional data sources is that it's not only you who is going to have those ideas, but a lot of other people come up with similar ideas. And what happens is if a lot of people implement very similar algorithms and they use very similar, if not exactly the same data sets, then these algorithms are going to perform in a similar way. What we want to avoid is to have the same outcome or a similar outcome to basically our competition. So people who are trading or they have the same interest in the same industries or sectors that we do. That's why it's very important to look at other data sources in addition to what we traditionally have, meaning the pricing data.
Maybe this is an obvious question, but I'll ask it anyways. Why would it be a bad thing if everyone had the same data and ran the same algorithm? What would be the outcome? Could I still be a good performer in the market?
Well, that is the problem. The idea is that you want the surplus and your colleague has exactly the same intention as you do. The problem is that you are not going to reach your alpha. This is the holy grail of every financial company out there. They want to generate alpha. And unfortunately, if everybody uses the same data and the same or very similar algorithms, it is not possible to generate alpha anymore.
What is alpha?
Just a second. We need to come up either with better algorithms or more innovative or more interesting ways to tackle the problems, or we need to come up with different data sets, or a combination of the two. Alpha is the surplus, or how I can, with my algorithm, reach the surplus that the market can generate. If I am implementing a very novel algorithm that very few people have thought of, be it that my algorithm is a lot faster than other algorithms out there, or I have very interesting ideas of how I can implement the certain algorithm, or I have such a unique data set that nobody else has, and this data set has such interesting and such useful information that I can pull a lot of signal from this data set, then I can be, let's say, smarter than my competitor algorithm, and I can have a bigger share of the market surplus than my competitor. Otherwise, if my competitor is better than me, then he is going to be the one who gains the market surplus.
So we've had, in the last, 10, maybe 15 years, strong growth in the amount of data available and interesting data sources like Wikipedia and Twitter. Could you give maybe a quick rundown of some of the interesting things you've considered that might be informative about the market?
In terms of the data sources out there.
Yep.
First of all, unfortunately, there has been little work looking at different data sources for finance because it's much more work and it's much more difficult compared to traditional data sources, which are already, they come in a very nice format, they are numeric, so it's pretty straightforward to use them and just feed them into an algorithm as input data and come up with the model on top of this particular numerical data set. However, there's a lot of unstructured data that does not come in this very nice format. This could be, for example, annual reports or very interesting broker research. Another example would be conference call transcripts or investor relations presentations. You could have various news from the likes of Bloomberg or Reuters, or you could have press releases. In some cases, there's in-house content that the analysts are producing for various sectors. These sources are only text-based. If you look at even broader type of unstructured data out there, so if you look at image data and geo data, there's a lot of untapped unstructured data. But the drawback is it needs a lot more pre-processing in order to reach the quality of its counterpart, the numerical data which we had for quite some time now.
Yeah, that pre-processing does seem to be the key. If I just did something naive like, got term frequency counts out of a document, I doubt if the number of times the word profit is mentioned, let's say, it correlates very well with the stock price. So what are some of the steps to turn that unstructured data into useful signals?
It's a lot about cleaning the data. Mm-hmm. Actually, there's two approaches. One approach favors very much data cleaning, so the pre-processing that you were referring to, where you would usually take, let's say that we are looking at text. In some ways similar and in other ways different approaches can be taken for image data and other types of unstructured data, but I will only focus on text for the moment. Specifically for text, you would need, depending on the application that you are looking at, you would do typical pre-processing steps to split your text into its main components, then identify, we call them tokens, the actual units that form your sentence or paragraph. Depending on the application, again, you need to identify, for example, named entities. So if a certain token refers to the name of a company or the name of a person or a location for finance, very important dates or the numerical data that you can extract from the text itself, then you might want to understand what are the connections between these entities in terms of which entity in relation with which other entity. For example, if you're talking about a CEO of a company and the CEO is named in text, then you want to extract this particular relation. So the fact that a certain person is the CEO of a certain company. Another thing that you can do is to extract events. For example, for finance professionals are mergers and acquisitions. So when a company acquires another company, and there's various ways in which you can express that. You can say that, for example, company A acquires company B, or is interested in a certain company, and that already is a hint that there might be a certain acquisition pending, and so on. Depending on the application that you are looking at, there's a variety of pre-processing steps that you might want to do. And then, of course, there's the other approach to tackling this problem. Here I'm referring to the deep learning approach, where instead of doing a lot of pre-processing, or maybe in addition to doing some pre-processing, you would feed a lot of this unstructured data to your neural network to pull different relations, for example, or different entities. So yeah, there's a variety of ways to clean up your data, to prepare it for the next part of the pipeline.
Maybe if for the moment we just entertain the listeners who know some of the technical details, could you provide a basic overview of the analysis steps you took?
Sure. The presentation was given at PyData London and PyData Berlin, and I was looking at two data sets. For London, I was looking at the FTSE 100. In Berlin, I was looking at the DAX. By looking at two different data sets, I could have a better understanding if the signal that I am getting is actually useful. The fact that for both of them, the results were convincing was very interesting and a very important finding as well. The analysis was as follows. I was looking at these 30 or 100 companies in the respective indexes, and you can get this data pretty straightforward because there's lots of providers for pricing data. If somebody has the idea of just downloading the data, it's available. So you have platforms like Quandl that you can use in order to pose your own trading strategies, but also to get data. In order to compute Wikipedia similarity based on text or based on graph, you need to preprocess the Wikipedia article, and then there is a library called Gensim if you are using Python, or there are different other libraries that have implementations of various types of shallow or more sophisticated neural networks that you can use, or not necessarily neural networks, you can use other types of approaches in order to build a vectorized representation for each company. Once you have that, then you can obtain pairwise similarities for the companies in your list. On the other hand, related to the pricing data, what you need to do is to obtain daily returns for each company in your index. If people are interested, there is a GitHub account where I've posted all the necessary code so they can just try it out. In the last step, you have on one hand the similarity computation, on the other hand you have your daily returns, so you can calculate the correlation for each possible pair. The final step was you can apply straightforward linear regression in order to compute your metric. In my particular case, I was looking at R-square, and then actually use it to decide if there is some meaningful signal in the data or not.
You know, when I first heard a little bit about some of this work, I started out a bit skeptical because while I'm not in finance, one thing that has been shown to me is that often people who make predictions about the market, on average, they do no better than an index fund over time. So I was thinking, well, if you go on Twitter or something like that and people are saying, buy this stock right now, that if they're not a useful signal, then just extracting it wouldn't be useful. But it sounds like you're doing something more clever, that you're looking for relationships and different events. Is that a good way to think about it?
The important thing to have in mind is what is the task that you are looking at? What is your problem? What is it that you want to solve? Because even in finance, you have different problems. If you are solely thinking about trading, then of course, just by looking at suggestions that people have on Twitter might not be a very good way to tackle the problem, because if we are looking particularly in the case of Twitter or other social media, you don't know the quality of the source. The first question that you need to ask yourself is, who is this person behind the Twitter account, for example? Mm-hmm. Is this person credible? To what extent shall I believe this person? Once you have that problem sorted out, which is in itself a very interesting research problem, then you can say, okay, so maybe this Twitter account, it suggests me to buy or sell a certain stock. I will assign this Twitter account a certain, let's say, credibility score, and my model will consider that particular suggestion or recommendation to the extent that I believe the source. That would be one way of looking at it. Other things that you can do with Twitter or with other social media data is to use them as information sources. For example, if you go back to the event detection problem, you want to know that a certain event happened, but you also want to know before your colleagues do. And maybe your colleagues are using Bloomberg or they are using Reuters as their data source. Usually information in the news appears a bit later than it does on social media platforms because let's say that the editor of the news piece, he decides that he first wants to write a very short message on Twitter announcing the scoop and then have time to elaborate on the story and then publish it. You can use social media information as a source of more timely information, and that can help because then you know certain pieces of information earlier than your counterpart algorithm, which is using news as its data set.
So in your talk, you described Wikipedia as an unconventional data source. What makes it unconventional?
Well, unconventional for the finance professionals because it is not really the typical data source that you would use. The talk that I gave is more like a teaser to make the community aware that there's a lot of untapped data sets out there that they might not think of at the first glance, but they actually do offer useful information. You can think of the algorithm that, let's say, makes a trading decision as a very complex algorithm in which you have a lot of input coming from different sources. One source could be something that maybe your counterpart has not thought of. Another reason for using Wikipedia is to say that even with Wikipedia, even with an unconventional data source, a source that it might not be the first data source that you would think of to use as input for your algorithm, even with such data source, you can obtain results. So if you would use better data sources, curated data sources, then your results would improve.
So we talked a little bit earlier about the challenges of extracting information from unstructured data. Certainly Wikipedia, even though it has some structure, most of it's just text. Could you talk about Wiki2Vec and some of the other tools you use to get insights from the text on Wikipedia?
The idea in the talk is to use different ways, I call it different views of Wikipedia. I can use the text itself, and then I chose a very shallow neural network in order to build my numerical representation starting from the Wikipedia article. And then you can also have a graph view of the Wikipedia article in terms of interconnections between entities mentioned in the article. So for example, if I'm looking at a specific company and in the same article different companies are mentioned, then I establish a link between these companies, looking at different Wikipedia pages that you can build a graph with interconnected articles. And by traversing this graph, you can also obtain information about how related two companies, means two nodes in this graph, which in this case are Wikipedia articles, how are they interconnected?
I can see where there's a lot of interesting insights to come out of that. It sounds like the main one you were looking at is similarity. Is that right?
Exactly. So maybe one extra comment to the graph part. There's different ways in which you can build the graphs, and there's quite some research behind how you can build these graphs because Wikipedia has a lot of additional information. For example, if you look at Wikipedia categories, that's one source of information that can help you in order to build these graph structures. And yes, the next step is once you have these representations, be it a graph or a numerical vector that describes the content of the article, then the next step is to compute similarities between vectors or between nodes in the graph.
To me, it seems like companies that are closely connected are probably related in some ways, and then you start to see these interesting industry phenomenon like, I don't know, if the price of oil changes, that probably affects all the gas companies in some way, maybe some more than others, but the index, if you will, goes up and down. Is that the same essential concept you're pursuing?
Exactly. So based on the similarity between different vectors or different nodes in the graph, you can observe different relations that exist in the market. You can observe how in a certain industry you have different players that are more related. if they are more related, then you also assume that they are going to perform in a similar way. The reason why I had the idea of doing this in the first place is a lot of times you do not have information about a certain company. You do not have its financial performance. So if you are looking at the time right before an IPO, you don't know what pricing data that company has. So there's no way for you to model that company. But if you are looking at the description of the company, so you know that this company belongs to a certain industry and has a certain range of products and has a certain distribution chain and so on, then you can look at similar companies for which you know the information already, which already had their IPO, you have your pricing data already, then you can make a more educated guess on the performance of that company.
And what sort of correlation did you find in that analysis?
I was correlating the daily returns, so there's a bit more data processing that goes in there. In terms of the examples that I was looking at, I found that the Wikipedia similarity does explain, to a certain extent, sure, correlation of returns. There is a certain amount of information that we can extract from analyzing text or graphs. I was also measuring this. I was happy with, let's say, a value that is 0.2, for example. A value close to 0 would mean that there is no information that you can extract from analyzing text or analyzing Wikipedia graphs. And a value close to 1 would mean that you can explain everything, all the information that is encoded in this pricing data, you can also explain using text. So a value of 0.2 tells you that there is some information that you can extract from the Wikipedia text itself.
As you were mentioning earlier, getting an improvement requires better algorithms, better data, or both. If someone is also clever and thinks to look at Wikipedia, you have the same data as them. How much do you think the algorithm contributes here? If someone were to dedicate their whole life to adopting your method and improving it, could they ever get it to 1.0?
No, definitely not. Even if we were to find the best algorithm and the best data set and so on, the tricky thing about finance is that it's not a science like, for example, physics, where you have a phenomenon, you observe it, then you build a model, and you can replicate the phenomenon that you are observing via your model. In this case, the problem is that in the financial market, the players in the market, they react to everything that happens. So, for example, if I write an algorithm today that observes some abnormality in the market, because the markets are not perfect, we say that this is going to be priced in very fast. The price is going to reflect that abnormality, because the more I am going to trade based on using the algorithm that I just came up with, the more this abnormality is going to disappear. And then I have to come up with another algorithm and another algorithm and so on. Because the observation itself is constantly changing, you need to constantly adapt your algorithms and come up with better data sets, and be more clever than your counterpart and so on. This is what happened also with the price data. It's not enough only to look at pricing data at this point in time, because we have been doing this for the past tens of years, and all the information that we could have pulled out, we already did. So we have to come up with more ingenious ways. As I said at the very beginning of the talk, either we come up with different data sets. There's companies that prefer to build these data sets in-house so that their competition does not have access to them and therefore cannot use it to build algorithms based on it. Or we come up with more clever algorithms. And I personally think that it will be a combination of the two. You need smart algorithms, but you also need high quality data. And then sure, as time goes by, the market is going to incorporate changes that are inflicted because we are writing these algorithms. So then we have to adapt to that and come up with yet different algorithms. And it's a never-ending cycle.
Sure. I know in a lot of financial models, it's not my area of expertise, but I have a rough understanding of it. Often they get pretty complex with time, mostly for some of the reasons you're describing it. There's this arms race of adding in new signals and new clever approaches. So it seems very obvious to me that the correlation data you've uncovered could be a useful input. Is it a useful prediction on its own? Could you go start a hedge fund based around this approach?
It's more, the presentation wanted to make finance professionals aware that there's definitely an untapped source of data and that they might gain a lot of benefit if they were to look at this data. Now, of course, there's more to it than just a few lines of code that somebody writes in a couple of hours in order to start a hedge fund and actually trade on that. However, there are hedge funds that look purely at unstructured data. My opinion is that we should not disregard the numerical data completely, but have symbiosis of the two, to have unstructured data, because this gives you an edge compared to your opponent that maybe does not have the in-house knowledge or has not adapted yet to the new area. That gives you a head start. But sure, as more and more companies are going to see that there is actually a benefit in looking at different types of unstructured data, then there's going to be more competition. We are going to see more diverse data sets or different types of ideas that are going to yield the alpha that everybody is chasing for.
Mm-hmm. I've always been impressed with Wikipedia because, in my assessment, it seems to pretty quickly converge to truth. I've seen a lot of instances where it gets updates very quickly, even faster than the news cycle, as you were mentioning, and that it's sort of self-correcting. So even if someone posts something bogus, it's there for a time, but generally someone will go revert that. So I was glad to see your talk. It was convincing to me that there's good evidence that a lot of signals available in Wikipedia for those that want to chase it. Could you talk about or maybe hypothesize some other things people might look at? I know the graph analysis is interesting. Maybe we could also look for, I don't know, how scandals affect companies. What are some of the ways the work could be extended?
The nice thing about Wikipedia is that it's community-based. It's not only one person's opinion, but you have a number of contributors. And yes, as you said, this information gets updated, and there's a lot you can do around the organization of the company itself, because in Wikipedia you have the entire history, or a large part of the history of the company, and how the company was split, or there were spin-offs, or it acquired other companies. So if you have an application that depends a lot on how a company grew and what kind of industries or what kind of sectors it incorporated over time, this kind of information you have available in Wikipedia. And it's curated and it's of high quality. Again, it depends a lot on the types of applications, and there's surprisingly everybody or a lot of people think when they talk about finance, the image that we have is the image of the trader, but there's so many more applications that can benefit from diverse data sets. So let's say that somebody is interested in different topics that are, let's say, hot topics for different countries. So, for example, you have copper mining in Bolivia, you have labor rights in South Africa, you have macroeconomic issues in Southern European countries, and you can use social media in order to detect trends. In some cases, these trends can precede the agenda setting of the financial media. So you can discover pieces of information, maybe because you are specifically looking at social media in the language of the country and it's not yet translated to English, or because you observe that certain activists tend to use a certain social media platform because this is very region-specific or country-specific, and you can therefore be able to identify FX or fixed income trading opportunities earlier on. And then additionally to that, if you are able to determine how trustworthy the source is, if the account that's writing the information? Is it a reporter that has a very high reputation? Is it a person which has a lot of experience in that field? And so on. This can give you additional signal in terms of how you are going to model the type of data that you are looking at. You could use, on one hand, data which changes very fast, where the rate at which this data is produced is very fast, as in the case of social media. You could use data that is of high quality and it's produced via a collaborative mechanism, as it is the case of Wikipedia. Then you also have structured versions, because there are certain projects that already have looked into making Wikipedia and other types of platforms easier for machines to process. Then you can look at projects like Wikidata, projects that already take the unstructured textual data and have provided in a more structured format. Then you can use this in order to build the different types of algorithms, as I mentioned before, if you are particularly looking at how a company develops over time. Then you can look at the conference calls. If you have a certain company that publishes its annual reporting, so in that particular presentation, they are going to mention certain future developments or ideas of how products or brands are going to develop over the year, depending on how the leadership of the company replies to questions from financial analysts. You can already beforehand have an idea of the outcome of the company before the numbers get published. There's a lot of applications, and each application might benefit from one type of data set or the other.
For a long time, I've looked at finance and I've been a bit intimidated because I think, well, there are such big companies and such smart people doing all this for such a long time. They know the models very well. But your talk gave me a little bit more confidence that it might be worthwhile for an aspiring data scientist to go out and explore some new data source or something like that. Do you see it the same way?
I think that right now there's a lot of opportunity for people to learn different techniques. You have a lot of online courses. Then there's a lot of opportunity to try out different data sets, because you have platforms like Kaggle and others that offer the data set for you to test your ideas and build your algorithms, and even look how your algorithm compares to other algorithms out there. So I think it's a lot easier, and it's not necessarily that this is a monopoly of big corporations, because the data is available. You need to come up with the algorithm, but additionally to that, there are platforms that enable you to compare, to learn from, or share your experience with other people. So there's a lot of resources that they are very easily accessible and make it a lot more interactive on one hand, and enable people who have ideas to try out new things.
Very cool. Definitely agree. Well, Delia, thank you so much for coming on the show and sharing your insights and going through the talk again. I think this is really insightful.
Thanks a lot for having me.
For more on this episode, visit dataskeptic.com. If you enjoyed the show, please give us a review on iTunes or Stitcher.